Hello and welcome to my series DevSecOps. Today we want to have a look at polyglot systems and why they are leading to polyglot security issues. If you want to know what to do against it and how you can start working in this field, stay tuned. Why polyglot environments lead to polyglot security hole. This is one topic we want to discuss right now, and for this I want to have a better view about the actual architecture that's often used right now. But I want to say that if you're using cloud native or if you're using a monolith or whatever, it's always the same base ID behind it. The better view cloud native, why I want to have it, because this is an architecture that helps us to understand and split it down a little bit, what I want to explain right now. And it's a very good example because cloud native environment is per definition a polyglot environment. And polyglot environment means that you're using different tools, different languages and so on. But let's start with the beginning here of this cloud native architecture, just as a bird's eye view. Cloud native architecture means that you have service-oriented architecture, and the service-oriented architecture means that you're splitting up the whole bunch of use cases in dedicated services, and then you're just composing the services to your whole business case. This is one thing that is interesting to know. We had this approach quite often with SOAP, SOA, whatever buzzword you want to use, but we are now going with this term microservices more and more in this direction. So we have this independent use case or process or service or whatever you want to say, and then you have this API in between so that they can communicate with each other over different versions and languages and so on. So what we can do is that at this point we're assuming that we have something running in containers, and this will be then managed by the term DevSecOps. And this is the interesting thing, that they switch from the term DevOps in the definition to the term DevSecOps explicitly. So why they are doing it? They are doing it because with these tiny split ups you're able to build simple services, and then you're just focusing on the simple service and you're providing this service API so that everybody else can consume it. So you're not depending anymore on some other behaviors. You're just using APIs to communicate. So that's good. So the split up will mean that teams can now working concurrently on a bigger project. This is good as well. But on the other side, you have the freedom to choose what technology you're using inside this service. So if you're using a new technology, it means that you can transform existing knowledge, for example, from one language to another language. But it means at the same time, if you're a senior in one language, you're not explicitly at the same time senior in other language. So you have to learn, you have to transform. Sometimes good if you can transform knowledge from A to B. Sometimes it's not good because the rules are different. So with this you have different technology stacks per microservice, and everybody would more or less agree that different technologies will have different behavior, different toolings, different performance inside or for the production and so on. But one good thing is with the splitting up in tiny things, you're mostly discussing about a rewrite instead of a maintenance or a refactoring. So this is a big shift in this, and this means that you're easily motivated to, or you're mostly motivated to throw it away and rewrite it, even with a new technology or with the same one, instead of refactoring. So this is one thing. If you're now grabbing one piece here out of this, so one single microservice, and we're looking at this tech layers. So the microservice can be Polyglot, so microservice A in language A and microservice B in some other language or runtime environment or whatever. But even if you're looking inside one microservice, we have different layers. And if you're looking, we have this application layer where we are coding some stuff. For example, the Java program, we are creating a jar that will run inside an JVM, and then we pack it in Linux, because this Linux we want to manage by Docker. And after this is wrapped in Docker, we want to scale it or orchestrate it in Kubernetes. So if you're looking at this tech stack, we will see that with every layer, we have a new kind of technology or a new ecosystem. And this means that we have, for example, for every layer, different kinds of vulnerabilities and compliance issues that are coming together. So for the application, we're doing it, if you have a vulnerability inside the Java application, for example, this vulnerability is existing in the Linux layer as well, because it's just existing there. If you can use it, or if this is a critical thing inside the Linux layer, it's a different question. But what we can agree on is that with every new layer, we're adding more vulnerabilities and different kinds of vulnerabilities, and the same with compliance issues. So there is a term for DevSecOps called shift left. I don't want to explain the whole DevSecOps or term in general. I have dedicated how-tos about this one, so check out my YouTube channel, and then you will find different explanations of different topics of the DevSecOps part as well. But the polyglot thing here, or what I want to use here, is first of all the term shift left. So if you are rotating this picture 90 degrees, you see that the application is on the left side and the Kubernetes one is on the right side. And shift left means that as early as possible you want to fight against compliance and vulnerabilities. And this is a good advice, because everything you're killing one layer before isn't existing in all other layers. So the first layer is very important, because this will be wrapped and wrapped and wrapped and so on. So killing vulnerabilities in the first step is one of the main goals you should be aware of. So looking at this tech stack in general means that if you're, for example, writing a Java program, then you have some kind of dependencies managed by Maven. And for this you need Maven repositories. And then you have this Linux, and if you want to deal with updates or security patches, you're dealing with Debian repositories, for example. On the Docker side, you have some Docker registries, because the first line in a Docker file is a from statement, and it means even there is at least one dependency, and then all the operating system dependencies and so on. And then you have the layer of Kubernetes, this Kubernetes universe, and here we are dealing with Helm charts, for example, because with Helm charts I can just provide bricks of full compositions of different Docker images or runtime environments. So with every layer we have more service, or it's more convenient to deal with, because we have a more abstract way of dealing with operating system, or with a lot of instances of an operating system and so on. But on the other side, we're adding with these tech layers different challenges. But there's one way, if you're thinking about these tech layers like dependencies, or they're mostly dealing with dependencies. The amount of dependencies is quite dominant here. I have a dedicated view on this one in my YouTube video about the low-hanging fruits of DevSecOps. Check out this one, then I will explain what is the impact of dependencies compared to others. Well, having this in mind, that you're dealing with these repositories and you're using Artifactory as a repository manager, because then you can handle all different kinds of repositories in one logical instance. And with X-Ray you can connect to start scanning against vulnerability and compliance issues. You have the possibility to declare rules and policies. These are the stateless definition, what should happen if you are able to find a vulnerability, or if you find a license issue, a compliance issue. How to create this one and what are the best practices with this. I have dedicated YouTube how-tos on that. One is called JFrog how-to rules and policies, and the other one is JFrog how-to about watches. There we'll explain how to connect to resources and what are the best practices and why you need them and what are the details here. But for you, right now, as a summary, it's a way to describe what should happen if you are able to find something, because with this one you are able to start with webhooks, external processes, and the interaction between systems. But one thing is here that looking at dependencies, you will find out that dependencies, using dependencies is good. Why? Because you're not reinventing the wheel. On the other side, dependencies are most open source dependencies. It means that you have to trust other people. They're doing it most likely in their free time. They're quite often not paid for it, and so on. So I don't want to complain that they're doing something bad or whatever, but it's good to check against known vulnerabilities, and it's good to check the compliance issues, because I'm not a lawyer, so I'm not really sure if I can combine different license, for example. And if I'm using a dependency with another license, then it could be a combination that's not good for your business. But I don't know it. I'm not a lawyer. So inside your company, a lawyer have to decide what compliance issues or what license can be combined for exactly this stage inside your project. So if you have done this one, you can define this one in rules and policies to scan for this, to be sure that's it. And this must be done over all transitive dependencies as well, because with every tech layer, you can imagine that you have a bunch of transitive dependencies. Just check out once, if you're dealing with Maven, for example, the transitive dependencies of common open source libraries. Sometimes they're just a huge tree. So hopefully always a tree and not a graph. Sometimes you have a graph, that's a pain. But in the end, what you need is, you need the decision make or buy. So make is you're writing it by yourself, buy is you're adding a dependency. And the next thing is you have to make sure that time to market is short, not only for use cases, but if time to market is short, at the same time you have a short amount of time to react. If there's a known vulnerability, you have to change the dependency and it's running in production. So time to market is not only the economic view on how to deliver use cases to the market to earn money. At the same time, you can use this as how fast you're able to react against non-vulnerabilities. So only if this patch is in production, then it will secure your business. So if you're looking at these different layers from the single node we want to have now, the single service, the application itself, this what you're coding, you have a huge, bigger amount of self-written stuff compared to dependencies, but with every added layer, you have more and more dependencies compared to the stuff you are giving. For example, on the Linux layer, most likely you're adding just dependencies and configuring, so you're adding just a few config files and so on. So at this point, I want to say the low-hanging fruits at this point for compliance and vulnerabilities is scanning the dependencies. And one good thing for compliance is compliance issues are just single points, so you have to eliminate them and that's it. But for vulnerabilities, you have the challenge that they are combining. You can combine different vulnerabilities, and only the composition of minor vulnerabilities can give you a major vulnerability for your whole system. So this is a critical thing here. So you have to check over all tech layers, all vulnerabilities to get the full impact graph. And only if you have the full impact graph, you can decide what is the amount of attack vectors against your system. So that is a thing what is leading us to some ideas. First of all, we have this time from there's something found and this information is available. Okay, if this information is public available, it's time to start your process, and from starting your process to this information that's available is now active in production. This is most likely the biggest part you can work on, and this is a time critical thing. So what is a good safety build against this. A good safety build against this one is just a good test coverage. So what does it mean? Test coverage means you want to have it very easy or comfortable to test it. And let's stay on this example with the Java application you're writing. You're a Java developer and now you have a challenge. You have the challenge to write as a server-side developer a web UI for your service. And now the challenge will start. What are you doing? So you will look around what is possible, because normally you're on the server side with graphical interface, you have nothing to do, but you need this admin interface that's available and it must be a web UI for whatever reason. So you can start checking around what are web standards, and the latest web standard that's really good because it's supported by a lot of browsers is, for example, web components. And with web components you think, oh, great, so I don't have to deal with this challenge that it's not looking different in different browsers. So you have these components, you can compose with this component something, and then you want to use existing components, for example, an existing button or an existing tree or table, and combine them so that you are fast with your development of your graphical interface, but this is not your main point. Then you're checking what technology is used for web components, and you will see HTML5, CSS, JavaScript. But you are a Java person, so oh my god, so a different language, different whatever. So you want to get rid of this one. So one in your team found out, oh, there is maybe an open source library you can use to abstract this. Okay, you found out there is this open source tool that will give you access the possibility to map this client-side web components written in HTML5, CSS and JavaScript to a core Java component. Great, so you're back in your tech stack, and this is great because then you can use your tooling. For example, you can use your JUnit 5 tests against the graphical interface you are writing. So you can create your safety build because you want to minimize the time from there is a change in my dependency up to running in production. And then you find out, oh, there's a stack Vardin, and Vardin, they have their own components, but they have a very generic layer inside. And then you can connect to completely independent web components. I don't want to go in detail here how to map this one, just as an example here, how it looks like, or how to map stuff. I have a dedicated YouTube how-to about how to map web components on the server side with core Java based on Vardin, and there's another how-to about how to harden the Vardin stack itself. So, but if you have this one, normally you have to deal with different technology steps. For example, if you want to have a web component, here I'm just showing the an example mapping of SIP UI5 web components to the Vardin Flow server-side implementation. What you need some kind of communication that's provided by the Vardin server implementation, and then you're creating a Java component. So then what you have some kind of npm install to grab some components. There's a corresponding annotation, for example, npm package and so on. On the website itself, you need something like an import, and this you can do on your Java side with an annotation JS module and then the declaration. And then you have to define what is a tag from the web component, and this you are mapping with the annotation at tag. So this is just to mention, you have different technology steps and you're mapping them one by one to the Java world. And what you will get here is that in the end, after you have done a few other things, that's not everything, but a few other things, you are able to have a Java class. For example, here this badge, and then you can use it like a core Java class. So new UI5 badge, and then you're setting attributes, you're adding attributes, you're removing charts, whatever, and you can use it on the server side. So this is great because now you're back on your productivity side, you're using your tool, your language, but what have we done now? What we have done now is that instead of just the application is now depending on the Java Maven world, we are adding the npm stack as well. And that means you have to deal with two kind of technologies, and with this, with two kind of vulnerabilities and license scanning. But for you as a developer, if you just getting from your colleague this convenience library, you say, oh damn, that's cool, I can write new badge, new button, whatever. You're adding a Maven dependency, but in the end you're adding 2 text layers without really knowing them, without really seeing them. And so at this point you need, for this Polyglot stacks, tools that will give you the possibility to scan against this Polyglot environment. And Artifactory will give you the possibility to handle the NPM repositories as well as the Maven repositories and a bunch of others. And with X-Ray, you're not only scanning the Maven part anymore, you're scanning immediately the NPM part as well. If you want to see this in action, I have a dedicated how to start with the IDE plugin so that you can have immediately, if you're adding this dependency, this vulnerability information inside your IDE reflected so that you can see and decide what's going on. And I have an example exactly to this one, how to harden the Vardin stack with this IDE plugin. So these 2 YouTube videos are available on the internet. Check out this one and you will see what you can do here. If you have this one, then you have now the possibility to deal with polyglot environments even inside your single node, your single service, without having hidden technologies that will bring vulnerabilities you're not aware of. Because if you have the full impact graph over all technologies, you can deal with them. Even if you're not familiar with this technology, you will see them and you have the possibility to check what's going on. So for this, X-Ray is used, and X-Ray is giving you the possibility not only to check via the IDE plugin inside your development process or inside your IDE, it will give you the possibility to break a build, to send emails, to start a webhook, to start external processes, as well as being requested or managed by REST API. So you have really the possibility of dynamic workflows and the interaction between different technologies and machines, for example, your auditing tool and so on. If you want to start this one, you need a free tier. How to start a free tier, I will show you in this video, JFrog how to activate a free tier. I will show you how you can start with this one. So you will get in 5 or 10 minutes an Artifactory and X-Ray instance. It's unlimited in usage of time. It's just limited in usage of space, for example, storage. And then you can start adding the IDE plugin to your IDE. You're just scanning your existing project and see what is the impact graph of vulnerabilities and compliance issues. But first of all, just focus on vulnerabilities. So that's it. Basic thoughts here are: convenience will lead to polyglot environments, even inside single services, and you need the full impact graph, not only over the whole architecture. You need the full impact graph even inside your single service. You need it as early as possible, so the shift left into the IDE is very convenient. And security shouldn't avoid the usage of convenient technology stacks. Security should just support you and make them secure and use them right in this place. So it means security is not slowing you down. Security is not breaking your convenience, but you need the tools that will help you to understand this polyglot stacks, because if something is very convenient, it's most likely combining different dependencies and technologies these days, and this is why I'm saying polyglot environments or technologies are leading to polyglot security holes, because the whole amount of vulnerabilities will give you the sum of attack vectors against your system. So that's it. I will go around a little bit here in the forest. I will make me a coffee soonish because it's a little bit cold. It's nearly autumn and winter soon. So that's what I'm doing right now. Otherwise, enjoy the rest of the day. Check out some other YouTube videos. Give me a thumbs up if you liked it. And I really would appreciate if you would be my next subscriber. Thank you so much and stay safe. Today we want to see how to create your own test engine for JUnit 5. That means in the beginning we will have a short introduction about the possibilities of the default test engine. The agenda for today. Why we need dealing repositories, what's influence and what part of your infrastructure is. The next thing is why you should have an eye on it. If you have this series about. It will be about functional reactive. And this for core Java means